Skywatchers! Welcome to an icy February version of our monthly interstellar discussion. So far this month, NASA has launched the Interstellar Mapping and Acceleration Probe, IMAP, on a 2-year mission to study the heliosphere, a sun-generated protective bubble that surrounds the entire solar system. The study will help scientists better understand the impact of our star on its galactic neighbors, as well as the interaction of solar wind on interstellar space. ESA researchers have built an AI model that combs through the 1.7 million images captured by the Hubble Space Telescope in search of anomalies. So far, 1,300 objects without appearances have been revealed. And once again, the Artemis II space mission has failed to launch. More on that in a bit. I'm Science Ben, let's transport outside and discover February sky. This afternoon, there's not much to see other than the sun. Local sky watchers have had to settle for diminished views for the past few weeks, given a prevalence of snow clouds blocking the light of stellar bodies. But tonight, in clear skies, just after sunset, can briefly be found 3 bright bodies: the planets Venus, Mercury, and Saturn. On the 18th, a sliver of a moon passes close by Mercury and Venus before climbing to Saturn on the 19th. Humans will not be launching around the moon this month, as the Artemis II mission has again been postponed. While the craft intended to perform the mission is in place on the launch pad in Florida, a concerning wet dress rehearsal last week delayed the rocket's launch for at least another month. Liquid hydrogen leaks, the fuel the rocket uses to go, have been identified as the main cause for launch delay. The same problem that caused multiple delaying of the Artemis I launch. The Artemis II crew was released from quarantine in Houston. They will again enter quarantine for a new 14-day period, 2 weeks prior to the next targeted launch date. NASA's SpaceX crew, 12 astronauts, today are wrapping up their 14-day quarantine in preparation for tomorrow's trip to the International Space Station. Commander Jessica Meir and pilot Jack Hathaway joined ESA astronaut Sophie Edino and Roscosmos cosmonaut Andrei Fedyev this past Friday to travel from Houston to the Florida launch site, while they will remain in quarantine prior to entering the SpaceX Dragon spacecraft. So, why so cautious? Are astronauts afraid of getting sick in space? Maybe, and they should be. August 6, 1961, cosmonaut Gurman Titov cruises around the Earth aboard the Vostok 2 spacecraft, the second person ever to do so. Following the first few trips around the planet, Titov begins to feel unwell and went on to become the first human ever to vomit in space. Quick reminder, liquids behave differently in microgravity than they do on Earth. The fear that Titov's former stomach contents would glob together and stick to important equipment was so grand that the Soviet Union canceled all human spaceflight for the following year, such to investigate and address the problem. Titov may have been the first person to experience space adaptation syndrome, a sort of extreme motion sickness for astronauts common enough that nearly half of all Apollo crews also experienced similar tummy trouble. Human ears have a liquid-filled vestibular system that helps maintain balance and that works with other senses like sight to communicate to the brain which way is up. In space, this liquid floats, which can confuse the brain, leading to disorientation and feelings of sickness. Seeing other astronauts floating around upside down nearby can further amplify these discomforts. In 1985, then US Senator Jack Garn flew aboard the Space Shuttle Discovery on a short satellite delivery. Garn was there to further study space adaptation syndrome. The research gained from the experiment was so abundant that Garn's name is not only associated with being the first senator in space, but is also used by astronauts as a unit of measurement for how bad they feel. One Garn being as sick as an astronaut can possibly feel. It's not just the physics that makes off-Earth illness extra challenging. The shared microenvironment of craft can lead to microbiological mayhem. The Apollo Command Module, used for the first crew mission of the Apollo program, Apollo 7, was a 10-foot by 12-foot cone that provided the 3 people aboard a cozy 210 cubic feet of volume to maneuver. 15 hours post-launch, Flight Commander Walter Schirra presented a bad head cold. Remember the whole microgravity liquid deal? Now imagine a runny nose that never makes it past the starting line. Unless you push hard. Hard. The cold quickly spread to the rest of the crew. While the mission was a technical success, the 3 men all emoted frustration and discrepancy befuddlement during their time in space. During their return flight, they initially refused to wear their helmets during re-entry for fear of not being able to blow their noses and the resulting pressure leading to eardrum rupture. They eventually agreed to take onboard decongestants, and the return proved successful. Not only can space travel affect the effectiveness of your immune system, but stellar stressors have also resulted in the reactivation of dormant viruses already present in space travelers. Remember that cold sore from 6 months ago? It's back! One way astronauts prepare for the possibility of surprise illness is to include medicines and other basic healthcare items in a mission's payload. Telemedicine has proven a valuable tool for more recent space explorers in need of consultation. But what if something more serious happens? Astronauts are human after all. What if one of them had a heart attack while in orbit? Traditional CPR does not work in space. Once again, due to microgravity. Performing side chest compressions would just push the two people apart. Experimenting with a variety of positions that included the use of restraints and a rear bear hug, scientists at University Hospital of Cologne, Germany have concluded that the best technique for CPR on the International Space Station would be to perform a handstand. The patient in cardiac arrest would be placed against one wall, and the responder would do a handstand over the patient's chest, using their feet against the opposing wall to apply compressions. Even with the best preparation, there are scenarios that are just too difficult to address in space. Surgery isn't happening on the space station, at least not currently. So in extreme cases, astronauts could be returned to Earth. But this has only ever happened once, last month, January 2026. NASA's SpaceX Crew 12 launches to the ISS tomorrow, but Crew 11 returned to Earth a few weeks ago on January the 15th, 1 month before their scheduled return date. NASA did not reveal the specific medical condition requiring evacuation, nor which crew member was experiencing it. Officials have revealed that all crew members were medically stable upon their return. We thank you for returning to the Void for this month's discussion. We're looking forward to warmer terrestrial temperatures and further discussion during next month's Void, the second Tuesday of March, March the 10th. We'll see you then. Thanks for watching, and keep discovering.